Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another Data Services Office Hour. I am Chris Short, host with the most here of Red Hat Live Streaming. I am joined by the one and only Chris Blum. Chris, how are things on your side of the world?
It is great. It's great to be back in the show.
I was about to say, yeah, you haven't been on in a while.
I haven't been on in a while. Yeah, this is, I think, the first time back here in Berlin. I
Mhm.
hope my internet is going to be fine for the next hour.
For those that weren't aware, Chris had to move himself because of bad internet at his home. So he had to move himself to an island in the Atlantic where fiber passes through so he could do his
And
job.
yeah, it was almost the only reason to move there.
Well, what do you expect from an island in the middle of the Atlantic? Fish
It
and
has
internet.
good fiber. Yeah,
Yeah.
definitely. So I looked at a calendar and I found out something really weird. We've been talking about ODF and OCS and storage and data services for a year now.
Wow.
And so I thought it's going to be time to actually reflect a little bit on our voyage. When
Mhm.
we started this channel, we wanted to teach Chris Short about storage. And
Have we succeeded?
have we succeeded? What does he really know?
Eh,
We probably have to test this in another quiz show. But
Ooh, good point.
yeah. So what I want to do today is I prepared a little video that is like a little remix of what we did a year ago.
Mhm.
And my goal is to reflect on that and look what's possible today. And for that, yeah, the video is like 5 minutes in total. We're going to stop at certain intervals and then look back. We're going to see that Chris Short sometimes is a little bit annoyed,
That
and
happens.
it happens. And it was a difficult show because you brought some hardware around your RHV cluster that was
Yeah,
by then not actually a supported platform.
right.
And to make matters worse, we also picked an OCS version that wasn't released yet. So just
I've
if you
started to
want to,
learn with Red Hat software that it's like there's a certain time when I should not use it, right? Like I've been trying to stand up single node clusters and get virtualization working. And that's very much tech preview, and it's very much not working on my box. So it's one of those things where it's like there is that happy medium of tech preview and working for me. I feel like sometimes.
yeah, and the thing is that um, we had to use it,
Mhm.
else your RHV installation wouldn't have worked at all.
Right.
But then on the other hand, we were using pre-release bits, so
Mhm.
that's not fun either. So it was like, yeah, what do we do? How do we fail? And it worked
Yeah.
after we spent a bunch of time on it. But yeah,
Nice. You want me to hit play on this thing?
yes, please do. And then we stop at the next city.
Yeah. You know what's funny is I said we were all set, and I lied. Um, because I was in
So
the wrong scene when we started. So just give me 2 seconds, folks. Um, so see, we're
Chris
already
was
falling on our
very
face.
brave earlier.
I was
He
very
said
brave. I did
he
something I'd
said
never
we're
done
set.
before, and I said, we're set. But now we are set, and the video is playing. This is a fresh cluster. I use the assisted installer to spin up a cluster here on an old Dell R820 that I bought because I need to run clusters in my house now as part of my job. So I've installed the OpenShift container storage operator and the local storage operator. So it's all these. This cluster is 6 KVM VMs just running in a Fedora host, right? Fedora 33 is the hypervisor here. So it's super unusual setup, but OpenShift should be kind of the normalizing factor across all of it, right? Like I should be able to install these operators and off I go. But we're having some weird issues because my disks aren't being picked up correctly. Is that the right way to explain it? And audio's on. All right. So
I was just saying, we were so young back then.
I know, like that was back when I was in my basement, unfinished. There's now frames and wires and plumbing is starting and all that fun stuff. So, eventually I'll get a nice finished office, not a temporary guest room.
Your equipment is fine. So if you guys were curious, that this is the show from a year ago. We can post a link in the chat. One thing I want to reiterate again is that this was a show on hardware that wasn't supported back then, and we did that on pre-release software. So the OCS version that we used back then was 4.6, which isn't too far behind. Nowadays we're on 4.8, so don't be surprised about that. And the video of this installation was actually done in November 2020, so not really a year ago, but approximately
Real close,
a year.
yeah.
Really close. And so nowadays we have 4.8, and I'm just going to try to share my screen again and then show you how that looks like today. So this is a 4.8 cluster.
Just
This
spun
is
up,
my cluster.
fresh, hot cluster.
Just spun up.
Yeah, I can tell.
It's still initializing.
I can just look at the dashboard and tell. You mind zooming in a little bit, though?
Sure, I can do that. So this is on vSphere. So this is fully supported platform now. We also support HV, by the way, now. And so one thing that was different earlier was I told Chris, please install the OCS operator and please install the local storage operator before we do anything.
Right. That was like a critical step.
Exactly.
At least for my infrastructure, yes.
And since we talk about the UX, we have simplified that now. So if we install the OpenShift container storage now, it will
nice.
Yeah, we'll automatically select the right channel. Well, we've had that before, but what I think we hadn't had back then was it will automatically create a namespace. It will automatically mark it for monitoring and everything that you had to do manually before. So it does that by itself. And this, I think we had a similar look here, similar user experience when you install OCS. But what's probably new is now when this is finished, it will prompt us to create a storage cluster. And we can't really forget about doing that anymore, because even if I skip this step, if I come back to the operator later, you will see a big banner telling you, oh, please do that now. Finally,
there's a thing you need.
Yes. And
you've come this far. Go all the way.
Go all the way, yes. And you don't need to install or know about a local storage operator beforehand. It will also prompt you when it sees that this is necessary. And we can see that in a second. And
if memory serves me right, we also had like some resource constraints as well that I had not taken into account. But now my understanding is there are smaller install bases available for OCS, right?
Yeah, we worked on that. I mean, it's not a huge step for a regular installation because our target is make your storage consumption as easy as possible.
Right.
And we don't want to come back directly and tell you, well, now you've done that. Now please give me more.
Right. Exactly. Yeah.
But for very small install bases, we have added more features where we can say we disable features. So, for example, you only have block storage, which is the most commonly requested type of storage. that saves you a ton of resources. Or we're also working on making the operator fit for the edge, where you only have a 3-node cluster, and where we want to see ODF as well. And for that, we will also look at reduced resources for that.
Nice.
So you already see this here. We've gone further in the operator. It's still installing, so the button is grayed out, but it's already telling us like, oh, you will need a storage cluster to go further. So if we're impatient and we've skipped a step now, if we go back to installed operators, we see it here and still installing. But if I click it, it will prompt us.
Oh, nice.
Now create a storage cluster. Don't do anything else. If you ever wonder where, well, I can't use the storage right now. Where is it? So let me just wait a little bit more. Here.
There we go.
The operators are running. Okay, let me try that. I don't want to mess it up.
It said installed. I saw it. I saw the green check mark on the operator hub screen. So you're good.
So since this is IPI, we could go the very easy route with internal if we have a storage class that provides us storage. This was always the case since our very first version of OCS 4. And this would work in here as well. But what we did, Chris and I, was we wanted to do internal attached devices. And as you can see here now, it's detected that our LSO operator is not installed. So what we can do is we can install that. Now with a click of a button, and we get directly forwarded to the install page of the local storage operator. So it's just clicking buttons that are there. Always click on the blue buttons, and that will be fine.
Yeah. And if you notice, folks, this is something that I like to reiterate every once in a while on air. Like the namespaces start with OpenShift dash. That is a system namespace, right? Like think of it that as like this, like you should not be mucking around in here unless you know what you're doing kind of thing on your namespace. Ooh, what you do? Changing resolutions on me.
Sorry.
You're fine. Back. It is. So yeah, like a lot of people think, oh, well, it's here, I might as well use it. And that's not always the case, right? Like we have operators to install monitoring stacks for things that are not the cluster. So we encourage you not to use the OpenShift monitoring bits for anything other than OpenShift, and then use an operator for monitoring specifically to monitor all the other things. Same with storage, right? You see OpenShift storage, that is not like a playground for you to just do whatever, and that means an operator is doing something in there, and whatever you do is probably going to get wiped out by that operator in most cases.
So before we proceed, maybe we start up the video again, because now we're at this stage where we want to install the storage cluster and we want to use the attached devices. And this will look familiar. So maybe you just play the video again and we come back.
All right.
So what we already have in this OCP 4.6.1 version is when you create a storage cluster, maybe Chris, you want to show that quickly. You do get a new nice interface. So if you've installed OCS before, this side actually looks very similar to what you had before. So this would use OCS internal, and it would try to pick up a storage class and provision storage based on that storage class. So that has worked before natively already with AWS and a couple of other cloud providers, VMware. And what's new now is on the top, you have that select mode, and there you can now select internal and external. And there we have integrated
storage attached, so you don't see it.
Yeah, we have integrated the magic of the local storage operator. And using that, it can theoretically scan for the disk and bring that all in there automatically, what you previously had to do manually.
Mm-hmm.
So the problem
So
we
I'm gonna hit
have
next
right
here
now,
because, so like, I have 3 available worker nodes. Hit all node next and see what happens. Oh, so we get to this wonderful screen where you set up your local volume set. So I'm just going to call this LVS000. 3 zeros is enough. Yes, select all 3 nodes. The disk type is SSD. Minimum node requirement is 3. Only 0 nodes match to selected filters. Please adjust
could
the
you
filters
extend
to
the
include
disk
more
type?
nodes. This one? Yeah,
Okay.
that's it. All right, and we're back. Sorry, Chris was refilling his coffee. So what did we see there?
We saw that you were trying to install it, and you might have heard this at the very end. Chris was a little annoyed.
You can tell sometimes when I get annoyed. It's amazing. Yeah. Like, I'm trying to maintain my professional composure, but damn it, this thing won't work.
Exactly. So it was due to the unsupported platform,
Yeah.
but on the other hand, also a problem that we saw on other platforms as well. Like on VMware, we also see that depending on what kind of data store you use, like sometimes it's a vSAN, even the disks don't get marked as SSDs. So
Right.
even in my cluster, a vSAN is based on NVMe disk, so the fastest you can get. But due to the communication between the Linux layer and the virtualized hardware layer, Linux thinks these are not flash disks.
Yeah.
Which is unfortunate because that, I mean, Ceph then also detects them as HDDs, and it doesn't do all of the modifications. Like it decreases a lot of caches. It tries to tune to spinners.
Yeah, it takes advantage of the faster disk, right? Yeah.
And because we want to support the OpenShift platform in itself for the logging, for example, we have so far not supported ODF on spinning disks. And now this provides the issue that in that particular version, we force flash disks. But then we notice that a lot of platforms, they don't fully mark the flash disk, that's flash disk. And a lot of customers came back and said, well, what do I do? We have a fix in the end of the video, which is going to show you briefly. It took the rest of the meeting, but then we succeeded. But it takes a lot of time to do. It is cumbersome. You need to go into the command line, you patch things left and right. You need to know a lot about your hardware. And that's not in the spirit of ODF. We want to make it easy so that someone can do it on a live show.
Yeah, exactly. Someone can spin up a cluster almost immediately before the show and do it.
You're teasing me a little bit.
Nah, it's a good tease.
Just a little bit.
I like the fact that it's like we're playing the video and your cluster's finally finished installing. It's good stuff. It's live streaming. It's right at for sure.
So yeah, so what we're going to do next is I'm going to show you how this looks like nowadays. So
it's a much better experience nowadays. Trust me.
Yeah, let me just prepare 2 more things here. This.
Are you screen sharing? Should you be screen sharing?
I'm not. I will in a second. Oh, actually I can start it. That way you can already look at this. So what I did while you were all looking at the video is I actually added a machine set to my cluster. I have a little script that helps me with these kind of things. So if we go to compute machine set, you will see that I have a worker machine set and I have an OCS machine set. And in the OCS machine set, I have a machine size that fits to what we need for ODF. And I also apply the right node label. And a lot of people underestimate that because they say, well, I have workers, I can just put ODF on there as well. The problem is sometimes in production, you lose nodes. And you're not supposed to treat your nodes as pets. You're supposed to treat them as cattle, and the machine sets are supposed to help you with that. So supposedly you lose one of your workers, and you have several, you lose it, and it's one of your ODF nodes. The problem is the machine set will recreate a node, but the new node will not have the ODF label. So ODF doesn't know that that node is supposed to be an ODF node. So that's why I always recommend create a new machine set. It can be just the same thing as the worker machine set, but add the OpenShift label to it. And you see it, we can scroll to it. It's obviously a little bit zoomed in, but
you can zoom out of this one layer if you want, or one level, I guess. There you go. It's YAML. People just kind of gloss over it sometimes.
Yeah, I don't see it right now, but theoretically you can put it somewhere in here. I think this is supposed to be where it is.
Yeah.
So I'm saying something that I didn't do.
Oops.
I guess I need to update my script, but please do that in production so that your new nodes, whenever you create it, have the right label. So with these new nodes, what I'm going to do is I go back to my operator in the right namespace, I click on storage cluster, and then I finally actually create that. I go to attach devices, and now this looks very similar to what we saw with Chris. And in the background, it installs, sets up the LSO stuff.
Nice.
Well, I think about a new cool name. And the new thing now, which is we have HTTP here. So that would have saved Chris George a lot of time. We can keep it at all. And we can even say, well, what kind of disk are we expecting? So sometimes, especially in bare metal environments, we have nodes that, for example, have multiple types of NVMEs. And we want to use a particular type. And the easiest way to do it is by selecting it by size. You select the minimum and maximum size, and then it's going to pick exactly that. But I'm just going to leave it like this. This will use any disk that is at least a gigabyte in size.
Nice.
And it can even use partitions now, and this is all fine. And it detected 3 nodes. That's right.
Nice. 6
with
disks.
6 disks.
Cool.
Let's go next.
Very
and it
slick.
will prompt us now. So we have the R features now. We can have a stretch cluster where we have 2 locations that actually have data, and then an arbiter node location, or sometimes it's called a witness. And that can be in a third site that's just very minimal. Some people even think about putting that into a public cloud. But that way you can have 2 sites with data. Apparently a lot of people have that. So we can have that. We don't need that right now. So sure, I can continue. this would be this tech preview
Yeah,
feature.
the enable arbiter bit. Yeah.
Now it's going to prepare the nodes and it is, and then eventually they come up here.
Yeah, so the operator's in the background doing his work, right?
Yes.
Finding disks, making them ready, that kind of thing.
Exactly. And yeah, means if we would have waited about a year, we could have saved a lot of time.
We could have, but then we wouldn't have been able to kick the tires and, sense the frustration.
But when we're started with OpenShift TV, I remember that Chris Short was explaining to me how the show works. And the surprising thing for me was we were allowed to fail.
Yes.
And people like it.
We embrace failure on this show, on this channel. The whole, please, people have told us straight up, teaches them how to troubleshoot, which is hard to get experience on. And then it shows people how we would troubleshoot things. So it's win-win when stuff fails, believe it or not.
And that is why I like doing live things, because I know things are going to fail eventually. Right now, it's all going good. We have our 3 nodes here.
Yep. There you go.
We can click on next. This is now new. So all of this page is new. We can now do cluster-wide encryption and also storage class encryption.
That's awesome.
So we can either encrypt the or both. We can encrypt the at rest, the disks that are used by ODF, but we can also, in addition, encrypt the disk inside of ODF, so that when someone would be able to get access to those, he wouldn't be able to use them.
If someone popped your cluster somehow, you'd be all right.
Yeah, and we can use an external key management system for that.
Can you uncheck
Currently,
that
we
box?
only
I'm
support.
Curious what? I was just about to ask what do you use support there? Vault?
Yeah, just HashiCorp Vault at this moment.
That's a good one.
We are thinking about supporting more, and but the basic stuff, the at-rest encryption, cluster-wide encryption, this is
that's awesome.
Just a checkbox. So you don't need to set up any difficult stuff. It's just this checkbox. As long as it's ticked, you're very safe. And the other thing is networking.
Yes.
So we've always had the default networking type where we just had those boxes using the default network. But now we've seen that sometimes people don't really have fast network. So sometimes they're limited by a 1 gig or 10 gig connection. And when you're really using storage, that can actually saturate that network with severe downsides to the availability.
Literally everything else.
Yeah.
Everything
is fighting for the network. So what we also have is Multus now, and with Multus we can separate the networks for the public, so between the pods that use the storage and storage, and the cluster network, which is an internal network just used for recovery traffic. And so we can use up to 2 specific NICs to route traffic via an extra route.
Do you need to turn on Do Not Disturb real quick?
Yeah, let me do that.
Yeah, just might as well. I feel like there's a conversation going there.
Here, and we're back.
And there we go.
So what I've seen, if we talk about VMware in particular, is we've had a customer that had actually very low bandwidth on the regular VMware environment, but then they were able to add a VMware switch. So the VMware switch was
Yes.
just able to communicate between the VMs, but it's super fast.
Oh yeah, lightning fast, yeah.
And so they were able to do all the storage communication over that network, and
Nice.
just have really good performance storage that wouldn't take away the regular network performance. But yeah, that's enough right now. We get a little review. We see how much total CPU and memory we have. We don't have zones here because I didn't add the zone labels. But we are enabling encryption, and we're using the full network.
Cool. And
that's done. Pretty much it. We can look at the pods. We will see that pods will spawn up, and they will be created. We will also see that we have PVCs that are being created eventually.
They be in storage or local storage?
No, in here. It just takes a little bit longer.
Yeah. Okay. Cool. Wasn't sure.
Or you can also keep looking at the pods. It doesn't really matter.
Watch the pods. Better than watching nothing. I like running pods.
Earlier, I had an SSA who was telling me, "Hey, my OCS operator, as soon as I install something, it's spinning into not ready." And I told him, "Well, it's always been that way." But I think not a lot of people they notice. But the OCS operator has a rather funny ready switch, which is actually looking for a file inside of the container. And that file is being treated as a little busy switch. So as long as the file is not there, you can usually assume that the operator is working on something. So it's totally fine if the OCS operator goes into not ready while it's actually doing something.
There's nothing wrong with the OCS operator doing stuff. Tell me one for the last part of the video.
Yeah, just for the fun, we've now seen the happy route. Let's watch the
route that makes Chris happy. Yay!
Hopefully both Chris's.
Yes, Chris squared.
So I've also added a little part of last year's video where we're trying to fix the problem. So what we did back then was using a machine config, we wrote a UDEF rule which would rewrite the local devices to SSD. So we would just say, well, those disks are actually SSDs, which they were.
They were. They still are.
And after about, I think, 45 minutes, we got that to work. And I shortened it down to a minute.
Okay, so 45 minutes of work in 1 minute of video.
Yeah,
so this should be very chipmunky. Yeah.
Yeah.
Yeah. Okay. Cool. Let's fire that up. You cool with that?
Sure.
All right. So, but this issue could crop up for folks that are setting up clusters in test or dev or wherever. But yeah.
So what we'll try today, unless there are more questions, we are going to write a UDEF rule with the help of one of my colleagues. He's tried that before. We haven't tried that yet. So this is similar to a cooking show, just during the office hours. We're going to try to apply a UDEF rule that will relabel Chris's disk to be SSD, and then they should be able to be used here.
Yes. Cool. Ta-da.
So,
We got it working. Ultimately, it was, a good experience for me to learn about how storage works within Kubernetes, how storage works within OCS ODF. And it kind of like maybe opened Chris's eyes to the idea of, oh, we could do better.
well, I always try to do better, but yeah, it's always different when you can confronted with actual real world problems, and then you see firsthand, like, okay, nice thinking. For example, the flash disk. It makes sense that we only support flash disk, but then sometimes it's not realistic to expect that these are always marked as flash.
Right.
And you need some kind of way to circumvent that. And detect this that might not be marked as HDDs, as SSDs, and mark them as flash disks. And now we got a solution for that. I mean, that's not the only improvement we did in a year, but
certainly.
as you've seen, hopefully, we've made the install experience a lot easier, especially for people that don't want to read the documentation.
What are you saying? I don't read the docs? That's so true.
Well, in a perfect world, you shouldn't need to read the documentation.
In a perfect world, you're right.
Yeah.
But no, there was a lot of docs I probably should have read to get a better understanding of how OCS did things before we did that show. You're absolutely right.
Well, it's not only you, but the thinking of the product always comes from your first couple of minutes with the product. You get a feel of the product, and if you run into issues like we did back last year, then it's possible you just file OCS ODF away and say, well, this didn't work.
Yeah. And to an extent, I'm like in that camp, because for me and my needs, ODF is kind of overkill, right? Like, I'm not going to need all that on just my local cluster here in the house, right? Like, it's a lot. I don't have multiple servers. I have one. It's all virtualized, et cetera, right? Like, no VMware. It's all just straight up KVM, So it's a very unique setup for me specifically, but now with like the local storage operator, it's way easier to do this compared to when we started.
Yeah, and all in all, we added a couple of features like the encryption, and we also added a lot of the DR and backup capabilities. But most importantly, we also made the user experience using the product. We made that easier now. And we listened to our customers, and we hope that the install experience is now to a degree that everyone could do it, even without looking at the documentation.
Right. Yes, that would be perfect.
So
there's so many there's so many different like configurations for storage though, right? Like, do you feel like all of those situations, or the 80% rule of situations is met here? I mean, have we advanced to that point in the past year? Have you been brought in on some oddball things?
It's always interesting. I'm just going to stop the screen share now. So this is installed. You've seen that. I'm just going to show you the PVCs one more time. You see how we're now using those disks. I actually gave each VM 2 100 gig disks. It detected all 2 disks, and we now have all of them here. They're available. And Nuba is always the first user of our new storage using the RBD class. One new thing in 4.8 is you used to have the dashboard for storage up here, but now
it's over there.
we see it down here, storage overview. So it's
Man, it's a lot more in depth, right? Like it shows you more. There's so much more on the screen now.
yeah. So they filed it back down here. This is for still installing apparently, but
Nuba, yeah.
this is going to be fine eventually. But this installation was okay, so I can stop the screen share.
Cool.
Yeah, so we try to focus on the regular experience of a user, and I think that
I'm an outside case. I'll freely admit that.
No. We've actually, in our SA community, we had a lot of people that had a very similar setup to yours and that wanted to run ODF on that, because that's the hardware we have around, and we need to demo it, and they wanted to install it there, play around with it. So totally fine. But we have our internal mailing list where our SAs to come back with customer questions. And what I've seen is that over the last year, the amount of exotic questions, like I found this thing here and we're trying to attach it and we want to stretch it over multiple sides and it's going to fail over. Can we support that? So the number of these exotic requests has increased. Whereas regular requests where people are asking easy questions, they've gone down to pretty much zero.
Wow. That's nice. And that has to be a fulfilling sensation, right? Like now I'm only out here in the wild. The city is fine behind me, kind of thing, right? Like you've built the city. and now you're kind of like, hey, everybody out in the wild, how you doing? You want to come in? Come on.
Well, I don't think that way, because I think why shouldn't we be able to support these wild ideas? And sometimes it's nice to have these look back moments, just like this meeting where we look back at the last year and compare that. But yeah, I don't lean back and say, well, we're done now, and these are crazy ideas, because we can also see how our customers they see a lot of features from our competitors, and they start demanding more things, and the maturity of our customers in the Kubernetes OpenShift world also increases, where a year ago people were starting their OpenShift clusters, and they were starting to put production systems into their clusters. But now they have their production systems in there, and they start asking these difficult questions. What about the backups? What about resilience? What about highly available stuff? And so far, Kubernetes just said, well, no problem. You get highly availability by having multiple pods. And then when one fails, it's going to spin back up. And that's nice if you can build your architecture like that. And some bigger customers, they still need multiple sites, and they need to be able to fail over between them. And even though a lot of people claim they can do it, it's actually a very hard problem.
Yeah, no, it really is. It's a hard problem. You couldn't have said it better.
And following up on the UX topic, but the user experience, we have ACM, right? The Advanced Cluster Manager. And this is our answer of managing multiple clusters. Yeah, just one platform that can manage multiple OpenShift clusters. You can install them, configure them, and even deploy your workloads. And we're going to put our DR story right in there so that DR is just as simple as our ODF install right now. That Chris Short can do it without reading the documentation eventually.
Or even knowing a lot about storage.
Or even that, yes.
Because, I mean, let's face it, right? A lot of times our customers are in that position where it's like, you're in charge of OpenShift and like their skill sets don't necessarily include storage or are somewhat limited when it comes to storage. So, a lot of the Linux admins of the olden days are now OpenShift admins, and making that experience with storage as nice as you have, I think, is very, very beneficial to those folks.
Yeah, and we try not to be limited by this label storage, and that's also why we renamed the product. We're the OpenShift Data Foundation, and on top of that foundation, we want to place data services that help you with your daily work. And Chris has already met a lot of my colleagues that work with data services that do very cool demos with Smart City and with X-rays that automatically detect illnesses on X-rays.
Yep.
And we have a couple of more demos coming up, but that is our goal, that we're not really needing to understand the storage. We don't need to necessarily talk about the IOPS. We can, but we don't need to.
Totally feasible, yeah.
But we have this trusted foundation where we know this is going to scale. And we just released a new version of RHCS, so Red Hat Self-Storage, the standalone product that doesn't really have anything to do with OpenShift. And with that, we've simplified the installation there as well. But we want to continue to invest in that because that can bring us the scale capabilities. For example, we always do our fancy testing with the object storage in there. My colleague Garan is he's doing the billion objects, and I think the last one was 10 billion objects he put into that object storage.
Wow.
And then we do the performance test, and we can see that without doing any modifications in the storage, we scale it for the target number of objects, but without any further additions, the performance is linear. You add more objects, and you never hit a spot where it just breaks down. You don't have any of those caching artifacts where you get the first 1,000 objects fine, and then it drops or something like that. We don't get that. So you can build that to a very large scale, and that's the power of this data foundation. You can just build it and put whatever you want on it,
which is totally awesome. Any questions from the audience? Now's your chance. If you haven't asked already, please do. Any storage questions for Chris or any OpenShift questions for myself, feel free to ask.
Or if you've been around for a year.
Yeah, if you've been watching us for a year.
Just say hello. That would be cool.
It's like, I remember this. Boy, Chris was mad. I am okay with admitting sometimes that I get frustrated.
I can understand it.
Sometimes too easily, right? Like, I've been working on it. Trust me, folks.
So far, you've never given up, and that's the most important thing.
Right. Like, I will never throw my hands up and be like, well, this is a bridge too far because it's just technology. We can figure this out. I say it's just technology. But it was built by humans, and there's no reason why us humans can't figure it out. That's basically kind of my whole modus operandi. If it's built by humans, then I, as a human, should be able to figure this out.
Well, if there are no questions, then one other cool feature that I might want to highlight is we have storage classes, and we actually have a bunch of storage classes when you install ODF. So let me show that again. So these are our storage classes. So this is the one we get from LSO. There's our local disk. This is the one we get from VMware due to the IPI install. And all of these here are being created by ODF. And these are for different use cases. So these down here are to create object buckets. This one is for block devices or file system read once. And this is for the read-write mini. Now, one feature that we just added is you can use the storage class and you can write annotations to the storage class and then use different pools inside of your Ceph cluster inside of ODF. So that's a very advanced topic. But for the folks that know Ceph, they know that you can have different pools. And with the pools, you can add different storage, let's say policies. And you can say, for example, only replicate twice, or only use storage in a certain location, or separate out data more or less. So you could say, I have 2 data centers with each with 3 racks. So one pool could be using just that one location, and the other pool could be trying to place replicas in both data centers, so that when one data center fails, your data survives. And you can store that in storage class annotations now. And that way you can get pretty fancy with these advanced topics. So right now, this is, as I said, very advanced. I can't say that enough.
But it's supported, right?
But we're trying to bring a lot of these topics back into the regular UI interface so that regular folks can use that as well.
All right, got some questions here in chat. All right, what happens when you delete a storage class that still has PVs in it?
Yeah. So I can actually delete a storage class.
Yeah, I was about to say, why don't you just do it, see what happens?
Yeah, well, right now we do have one claim here in RBD here. So the DB Nuba claim, and that is using the RBD storage class. And I can delete. I think it's going to be recreated immediately. So it's not like you. But the storage class itself is not really what has information here. The information in a storage class, so here you see it being recreated automatically by the operator because it says you need it, but you can delete it. But there's no direct mapping from the storage class. The storage class is only used when you create a PVC to figure out who to talk to dynamically create a matching PV.
Right, makes sense.
If that makes sense. And I think there's another question.
Yeah, so next question. And hello, Jose. Welcome. Please feel free to ask your question, Jose. But a follow-up question, will it be possible in the future to have ODF spread over 3 clusters, 2 active and 1 arbiter? Is it a roadmap item, or do you even have it out there yet?
I'm not sure what you mean with 3 clusters. Like, we have already now with our DR capabilities, we have the option of 3 sites. So you have nodes in site A and site B and site C, and site C can be the one where you have the arbiter, very small, and then you have site A and site B where you have your actual data. But if you have 3 separate OpenShift clusters, then that's going to be tricky.
Yeah.
And yeah, we don't do that.
And there's reasons why, right? Like, I think the idea is to build a cluster robust enough to fill that, use case, as opposed to building multiple clusters to fill that use case. But Penguin Whisperer, I am curious what your use case is.
Well, what you can do when I think about it, if you
He
really
means
have
3
3
separate clusters. Yes, he really means 3 separate clusters, not one stretch cluster. Yeah.
So if you have that, one possibility, but it depends a little bit on what kind of storage you need and how your replication has to look like.
How those nodes are connected to each other, that too, right? I mean, there's network layer there somewhere,
Yeah, but then we talk about synchronous and asynchronous replication. But what he can look at is deploying ODF in external mode, and just use a dedicated RCS cluster. And then you can have an RCS cluster can either also be stretched, or that one can replicate between the 3 sites. You could do that.
Good point. The idea is, okay, so some more follow-up. The idea is if the full cluster goes down, that's not easy to recover from. True. I mean, essentially your whole operation ends. But with 3 separate clusters, you mitigate some blast radius.
Yeah, but this is exactly what we target with our DR topics, where you have asynchronous replication, for example, and you have these clusters, and you want to have a backup cluster, so that when your active cluster goes down, you can switch over to that. So that's definitely insight for our DR topics. And we're working on that. And we'll have really good UX for that, but it's too much for today.
Okay, fair enough. And we are coming up on time, so last statement here. Let's see. If it's deployed in external mode, the replication has to be set up manually, right? That I don't know.
Right now, yes, but it's even trickier than that. So the storage replication with RCS is not that tricky, but what's tricky is getting the metadata of the OpenShift PVs and the application over as well, and that is being handled via our DR topics. So I have to ask you to just wait a little bit longer and see that. What you're describing is probably handled by our regional DR.
Yeah, the reason he's asking is that they actually did have a cluster that got completely trashed, and that would be disastrous in production. Yes, it would be. 100%.
Yeah, and we're aware of that.
Yeah, and you're working on it, so that's good.
We're working on it. We just want to make it extra easy to set up, and so that it actually works when you need it.
Awesome. So yeah, thank you, Penguin. That was a great series of questions there. So without further ado, I have a meeting I got to get to. Thank you, Chris. Thank you, audience, for participating, and thank you, everybody else, for watching. Stay safe out there, and we'll see you in 2 weeks with some data science stuff.
Bye-bye.